All right, so I'm just going to go through the whole 5.4 section of the workbook just to kind of clarify about percentages here. So I'll skip over this initial kind of introduction here. Oh, actually, sorry guys, I've got the wrong paper. There we go. Yeah, so there's like a little bit of an introduction there where they go through an example, but we'll try some of these other problems here. So the first one says the ages of members of a senior lawn bowling club are normally distributed. Okay, so we know that they follow the normal distribution. The mean is 65 years and standard deviation is 3 years. So mean 65 and standard deviation is 3. Okay. What percent of the bowlers is in each of the following age groups? So what you need to kind of be familiar with here is the percentages that you would find on a normally distributed bell curve. So just make sure that you do know these percentages like going into the test, because they won't be provided for you. So basically what we find with this is that like within one standard deviation of the mean, 68% of the data should exist within that range. For a normally distributed bell curve, and then 95% of the data should fall between 2 standard deviations of the mean, and then 99.7% should fall between 3 standard deviations of the mean. And this is true for all normally distributed bell curves. So what I might do is just kind of keep this here for us as a reference. So basically, if okay, so we basically have these age groups and we have our mean and our standard deviation. So if we're told the age group, basically we need to figure out like where is this falling on the bell curve. So if we're between 59 and 65 years old, 65 is the mean, so we're going down however many standard deviations. So if we do 65 minus 3, which is our first standard deviation, so that's basically I'll do that symbolically. So basically, if we're doing mean minus 1 standard deviation, then we're doing 65 minus 3, which is 62. Okay, so we're not quite at the lower end of the range. So let's try subtracting off one more. So let's do 2 sigma. So 65 minus 3 again, basically. So minus 6 gives us 59. So we can see that in this range, we are between minus 2 standard deviations and the mean, which was 65. So essentially we are ranging from mu minus 2 sigma all the way up to mu, okay? Actually, I guess I haven't really done a lesson where I talked about that. So just to remind you guys, mu is the Greek name for the letter that represents the mean, and sigma is the Greek name for the letter that represents standard deviation. So because we're within that age range, we can say that the percent of bowlers that fall into that age range is going to be this percentage plus this percentage. So essentially we're going to have 34% in the mean minus 1 standard deviation, plus another 13.5% found in the group that's mean minus 2 standard deviations. And so then that should add up to give us 47.5% total. Is so basically 45% of the whole club is between 59 and 65 years old. Okay, now if we go 68 to 74 years old inclusive, then we're already above the mean, right? So if the mean was 65 and we're at 68, we're up 1 standard deviation. So basically we're like mu plus a standard deviation, which is 68. And then if we go mu plus 2 standard deviations, we'd be at 71. So in order to get to 74, we're mean plus 3 standard deviations is 74. Okay, so the age range we're looking at is between 1 standard deviation and 3 standard deviations. So essentially we should be doing 13.5 plus 2.35. 13.5% found in the group between 1 and 2 standard deviations, and 2.35 in the group between 2 and 3. 2.35. And so we should end up with 15.85%. So basically what that's telling us is that close to 16% of the club is between 68 and 74 years old. Okay. Then they're asking for older than 74 years. So basically we just said that 74 was 3 standard deviations. So older than that is going to be within this range, outside of where we're given percentages. But because we know that 99.7% of the people fall within this age range, the remaining 0.3% to make it up to 100% are found on the outside 2 ranges. And then just keep in mind, because there is a bottom half of that, we have to divide it in 2 to represent the upper half. So basically we would say, here, I'll see if I can fit this all in the screen here. So basically we would say, because it's 74 is the mean plus 3 standard deviations. So basically what we're going to have is 100% of the people minus all the ones that fall within 3 standard deviations, so minus 99.7, leaves us with 0.3%. But because half of those are going to be on the younger age range, we have to divide that by 2. So we're left with 0.15% are over 74. Okay. Next one we have here, a teacher is analyzing class results for tests. And so the results of all 3 tests were normally distributed. So again, we know that they're going to fit that curve. Describe and compare the normal curves for tests 1 and 2. So this is basically just understanding what's going on, right? Both of them have the same mean, test 1 and 2, but test 1 has a standard deviation of 2.5 and test 2 has a standard deviation of 4.9. So keep in mind, when you have a larger standard deviation, all it means is that the data is scattered further away from the mean. So basically that means, like, for this test, you would have more kids or more students, who are closer to 85 as their average, or as their class, as their test grade, whereas in test 2 you'd have students who have tests that are more widely distributed from that median mark, or mean mark, and then if we compare curves for test 1 and 3, now you can see they have the same standard deviation but a different mean. And so basically what that means is both of them will have the same kind of level of scattering around the mean, but on test 3 the students on average had a lower mark, right, by 10%. Okay. Next one, determine Jasmine's marks on each test given the information. So we're using the same set of tests, but we need to figure out what Jasmine's mark would be. So all you need to do here is literally the math that it's telling you, right? We have the variables, the numbers for means and standard deviations. So for test 1, her mean was 85. So it's going to be 85 plus 2 standard deviations. So basically 2 times by the standard deviation of 2.5. And that gives us 85 plus 5, which is 90. So that would have been her mark on that test. For test 2, she got the mean, which is 85, minus 1.5 standard deviations. So 1.5 times 2.5 basically. And that's going to leave us with 77.65, so we round that to 78%. And then for test 3, she got the mean, 75, plus 3.5 standard deviations, so 3.5 times by 2.5. Oh, whoops. Sorry, guys, I just realized I made a mistake here. This should have been 1.5 times 4.9. I wasn't using the proper standard deviation there. Okay, but the answer should still be the same there. So now 3.5 times 2.5 plus 75 gives us 84%. Okay, so the nice thing about these ones is like when you have the like mean plus or minus however many standard deviations, is if you already have those values for mean and standard deviation, you can just plug them in as the variables into the formula and do your calculations. Okay, in this next one, is the data in each set normally distributed? Use a frequency polygon to help you explain. So basically what we need to do is we're given intervals, but the midpoints are blank. So basically we just need to find out what's halfway between 11 and 15. 15 minus 11 is 4, half of 4 is 2. So you just add that to the bottom number, right? So 11 plus 2 is going to be 13, is halfway between 11 and 15. 16 plus 2 is going to be 18, which is halfway between 16 and 20. 21 plus 2 is going to be 23, halfway between 21 and 25. Okay, and then we have 20, 28, 33, and 38 would be our other numbers. Then they want us to figure out if this is normally distributed. So the first thing would be you can kind of draw your frequency polygon, which is just a fancy way of saying that you're making a graph of the data you just plotted. And what you want to, or the data you just calculated, what you want to plot is the midpoint and the frequency. Okay, so when I tried this, basically I ended up figuring out 10, 20, 30, 40. Unfortunately, there's like just a few too short to do 5s, which would have been nicer to have like a little bit of a more spread out graph. And then I went up by 2s here, so 4, 8, wait, 4, 6, 8, yeah, 10, 12. I'm going up by 4s now just to leave myself some space. 12, 14, 16, and then did we have an 18? Yeah. Oh, that's weird. I didn't think I made it to the top. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's because that would be a 20. 20. There we go. Okay, so just plot the data. Basically, your midpoint for the first one is 13, and the frequency is 4. So we're going to go like that. The next one is 18, and it's going to be at 6. The next one is at 23, and it's going to be at 15. So let's see here, that'd be right there. 16, or sorry, 15. The next one is going to be at 18, and it's at 28. So if this is 10, 20, 30, and I want to be at 28 and 18. So 18 is going to be here, 28 is going to be like there. And then I have, let's see, 33 and 9, 8, 9, and then 38 and 4. So if here's 40, we'll back it off a little bit, and we're back at 4. So, I mean, it's not super tidy, and honestly, I'd rather do that on much bigger graph paper because you'll probably get better results. But even if we just kind of like approximate the shape of the graph, you can tell that it's roughly falling into like a bell curve kind of a shape, right? It peaks and drops off at the sides there. The other thing we can do to kind of confirm that is to look at our percentages and see if they fall within a normal range. So basically what you would do is find what are your middle 2 points. So it'd be like those two. And then determine what percentage of the total data they make up. So that means you would look at all the frequencies added together. So if you go 4 plus 6 plus 15 plus 18 plus 9 plus 4, you should find that there's a total set of 56 numbers. And this component, or these middle 2 terms, are 15 plus 18, which is 33, out of those 56, which if we divide that, that gives us 59%. And it seems like the ranges that are acceptable are pretty broad here. If we look at this one here we have 6 out of 56, which when we do that math gives us 11%. And this one is 9 out of 56. So when we divide that, we get 16%. So if we refer back to our normal bell curve here, within like the middle terms, we would expect to be close to 68%. We're at 59, so I don't know, it's like within 10%, so it's like reasonable. And then if we add on, because we would want to see how much if we add on these other two outside terms. So basically if we had the 59% from the middle plus the 11 plus the 16, that makes it like now we're talking about the middle four terms, we end up with 86%. Okay, so again, kind of like within 10% of this 95 range. So because we have two ranges that seem to match up with approximately with a normal distribution, we can say that we think that this is normally distributed. And then like if this was a word problem on a test, you would further support that by saying the shape of the frequency polygon approximates the shape of a bell curve. So that's more support that this is normally distributed. Okay, so that's basically how you do these ones. I'm not going to go through the two other ones because hopefully now you kind of understand what you need to do these, and it should be pretty straightforward from there on. Okay, so two more numerical responses here. So Reggie recorded the points he scored playing basketball during the year, and these are all of them. And the first thing you need to do is determine the mean and standard deviation of the set of data. Now, I do want to point out, if you guys are using the answer key for this, I don't know, some of their numbers translated weird because like I think I had the same value as them up here except for the standard deviation, but then down here they translated it differently. So if you're doing these kinds of calculations and you're off by like a couple of decimal places from the answer key, don't stress out too much about it. Because they might have calculated it in a bit of a different way. The way that I would recommend calculating this is to use your calculator. So if you're not sure about the steps for that, the first thing you want to do is go into Stat and you want to edit your list. And depending on what you have, like if you have something in L1 that you don't want in there, you can basically scroll up to highlight L1 and then you would hit clear and it'll clear the list. Don't hit delete because it'll actually delete like the whole list column. All you want to do is clear out the values. So basically if you want to go up there, you can go up to there, hit clear. I already have all these values entered in, so I'm not going to take that out. So basically you would go through and just go like 22 down, 24 down, 23, like go down and enter each one of these values. And then when you're finished, you want to calculate based on this list. So you go, actually, maybe I should just go through and check and see if that 0, 0, 3, 36, 28, 15, 0, 28, 32, 12, 11, 10, 31, 10, 32, 29, 14, 22, 21, 30. Okay, so yeah, all my values are accurate there, and sometimes it's good, especially when you have a long list like that, to just go back and double check. Now what I want to do is do my calculations. So I go back into Stat, but this time I'm going to scroll over to Calculate. Okay, and so I want to calculate the variable stats, so I'm going to hit Enter. You do want to make sure that what it's using to calculate is the appropriate list. So we had all of our values entered in L1, so that's good. If you ever needed to change it, you'll notice that down here we have like L1, L2, L3, L4, L5, L6. So if you had entered the list in a different column, all you would do here is hit second function and then whichever button to represent the list that you actually used. Okay, then you go down to calculate. And then you get this whole list of things that it's calculated. Basically, the main things you're going to be concerned with are the mean, which is represented with this X with a bar on top, just like it is in your standard deviation formula. So the mean is, we're going to round it to one decimal place, so 18.5. And then the standard deviation is the standard deviation symbol, or the sigma, with the x after it. So again, we'll round it to one decimal place, so it's going to be 11.1 for the standard deviation. Okay, and then basically we're completing a frequency table. So essentially all we're doing is saying, like you can use what they kind of figured out here for the how you're figuring out like the midpoint. So essentially, Oh, and that was, I think that might have been what they were doing there, now that I'm thinking about it. Sorry guys, I got distracted. And this is why I couldn't, yeah, the numbers that they had in the answer key were just kind of wonky. Like basically the way that I would do this is you have sigma minus, or sorry, mu minus 4 sigma. So basically you're going to take your mean and you're going to subtract off 4 times the standard deviation. So if our mean, so now I can, as long as I have this part written down, I can quit out of here. So basically for this first one, it'd be 18.5 minus 4 times by 11.1, which gives us, see, and this is where my values get a little bit different. So I don't understand exactly how they got this, because even when I actually used the numbers that they put in here, I didn't get the same value. So don't stress too much about it, the answer key being off a little bit. I got negative 25.9, right? And so then basically you would go, let me just think about this plus. So to figure out the interval, this is at minus 4 standard deviations. So the interval is going to go from minus 4 to minus 3. So basically, like this one says from 25.2 to 14.4, I would say from 25.9 to 14.8. And then if you want to find the midpoint, remember you need to find the difference between those two and divide it in half. So basically I would go 25.9 minus 14.8 divided by 2, which would give me 5.6 as my difference if I round to 1 decimal place. So then my midpoint would be negative 25.9 plus 5.6. So negative 20.3. Oh, sorry guys, that's probably not showing up super well with the light shining on it. So that would be my midpoint range. Okay. Now the nice thing is once I've calculated this, I can use that same value for all of the ones moving forward because it's half a standard deviation, right? So I can say 5.6 is going to be my difference to solve for my midpoint. So like for example, now if I go down to this one, although they have different numbers here. So I think their difference that they were using for these ones was 5.4. So we'll just do that for this one. So negative 3.6 plus 5.4 would have given 1.8. And then what you want to do is, so for the initial ones, they had frequencies of 0, and that's because there are no values in this set of data that fall between like negative 25 and negative 14.4. And same thing for negative 14 to negative 3, because you can't really score negative points in a basketball game. So basically then here we would look and say, are there any values between like negative 3 and 7? So don't round this up to 8 because it would only go up to 7 maximum because you can't have 0.2 of a point. So basically we're looking for between 0 and 7. So if we go through the data, there's 1, 2, 3, 4 data points that are between 0 and 7. Okay, so we'd fill that in. Then here, this row, we have to do the full calculation. So we would do the mean minus 1 standard deviation. So I'd do 18.5 is the mean we calculated, minus 1 standard deviation is 11.1. So that gives me 7.4. And my range is going to go from 7.4, which is the minus 1 standard deviation, up to my average, or up to my mean. So it would be 7.4 to 18.5. Okay. And so then basically now I would say any points between, obviously again, this is going to, starting at 7 and going up to 18 because we can't have that half point. So between 7 and 18, we have 1, 2, 3, 4, 5 points. Wait, is that right? I think I got more last time. It's between 7 and 18. I have 5. Oh, 6 and 7. There we go. So yeah, you got to be a little bit careful with checking your data. Can't zip through it like that. Okay, so 7 data points there. If I would just want to calculate my midpoint really quickly, it's going to be the 7.4 plus 5.6. So 13 is my midpoint. Same thing here, my midpoint or my median is 18.5. So my range is going to be from 18.5 up to that 1 standard deviation. So basically 18.5 plus 11.1, which gives me 29.6. My midpoint is going to be 18.5 plus 5.6. So 24.1. And so basically I need to find things that range between 18 and 29. So that'd be 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I think for this one in the answer book, also weird because their numbers were 18.5 and 11.3, I think, which would still add up to like 29 point something. But they didn't include 29 in their data point, which is weird because we're over 29 now. So we wouldn't be able to count something that was like, we wouldn't be able to count if there's anything that's, yeah, like this one, 30 you can't point or can't count, but you can count the 29. So I don't understand why they did that in there. It's just very weird. Then the next one would be mu plus 1 standard deviation. So basically we're going to have that 29.6. Right, 18.5 plus 11.1. That'll be the bottom end of our range. And then we're going up to the 2 standard deviations, so 29.6 plus 11.1 gives us 40.7. Oops, 40.7. And halfway between there, 29.6 plus 5.6 is going to be 35.2 is our midpoint. Now we would just go in and say, okay, so between basically 30 and 40.7, we are going to have 1, 2, 3, 4, 5 points. 5 frequency. Okay, and then again, we're going to have 40.7 starts here, 40.7 to 40.7 plus 11.1 gives us 51.8. And then the number is 0 here, so we have no more left. Okay, so I'm not going to go through these remaining ones. You could always fill that in using the same method we've been using. Then it says to create a frequency polygon using the grid provided. So basically all you would do is, again, you would want to have like your midpoint here, your frequency here, and then you would just draw out the points, you know, plot the midpoint versus the frequency. So again, I'm not going to go through that because it's mostly just you guys sitting watching me draw, but I will explain kind of like, they're asking, are his scores normally distributed? So partly you would want to look at your graph, which should actually end up looking somewhat bell-shaped. But the other thing is you want to figure out what are your 2 middle values and what percentage of the data do they constitute. So essentially, like we have 1 here, 1 there, 1 there. So these 2 are our middle 2 sets of data. So I'm going to look at those and say, okay, my frequency is 7 plus 8, 15, out of a total of 15 plus 4 is 19, plus 5 is 24. So 15 divided by 24 gives us 62.5%. So knowing that, and sorry guys, microphone cut out. So knowing that and looking at our bell curve, 68% is the normal range. We're within 10% of that, so that seems good. But we do also want to confirm by looking at how much do the next 2, like if we add in the next 2 sets of data here. So basically the middle 4, if we add those up, we end up with basically all of the data, right? Because these ones are zeros. So we end up with 24 out of 24. Get rid of this 5.6 here. So we end up with 24 out of 24, which is obviously 100%. And so that is again within 10% of 95. And so we would say that yes, we believe that the scores are normally distributed because, the middle points fall close to being 68% of the data, and the next kind of standard deviation away falls within pretty close to 95% of the data. And then if you had drawn your curve, you should end up with close to a bell curve. So use that as your final support for why you believe the scores are normally distributed. Last of all, we have a manufacturer offering a warranty on toasters. They have a mean lifespan of 6.5 years. So our mean is 6.5. Standard deviation is 0.5 years. How long should the toasters be covered by warranty if the manufacturer wants to repair no more than 2.5% of the toasters sold? So basically we want to figure out what age of the toaster will represent 2.5% if we think about a normally distributed curve. So essentially all we're looking at is if we have our standard deviation, 2.5% of the toasters will be the mean minus 2 standard deviations or less. So basically we want to figure out what age that would be. The mean is 6.5, and we want to have 2 standard deviations or less. So minus 2 times by the standard deviation of 0.5. So basically 6.5 minus 1, which gives us 5.5 years as the value that we want to have for how long the warranty would be. Now, you don't want to have like a half year in there. So just to be safe, you would probably say 5 years is the total length of the warranty that you should offer. Okay. So now you can see how warranties are calculated to make sure that they don't have to help you out too much. So anyways, hopefully that helped, and let me know if you need any more explanations about the percentages.